Hi everyone, welcome back to the channel. So yes, I am here after so long. I had not been uploading the videos since so many days, but now I'm here. I'll be active. I'll be uploading the videos every single day. Okay, so I'm sorry I was not active at all for from few days because I was in some work and now I'm free. So yes, I can be active from now onwards and I will be active for sure. So okay, so what about today's video? What I have brought in my this video. So today basically I'm going to solve questions. Okay, this video is going to be on the questions only. So today I have brought the topic limits and I am going to solve some very important questions of limits, some basic questions also, and some little bit tricky questions as well. So let's directly start with our video. So I hope you are going to enjoy this. So let's get started. So I hope my screen is visible and now let's start with our video. So as I said, the topic is limit. Okay. So this is our topic for today. I'm going to, of course, take questions only. I'm going to make you understand some very important questions of limit. Okay. So the first question that I have basically prepared right here. The question is, we have to evaluate limit. This is how we read the question of limits. Limit x tends to 0, root over 2 plus x minus root 2 upon x. I have basically received one comment that some people also want they are saying that they want to know about the class also, like which standard I am teaching. So I'm going to teach all the standards from 6 to 12 as like if you'll go into my YouTube bio, you will see that I'm basically covering from 6 to 12 standard. So this video, if I say particularly, is from class 11th. Okay, the topic you are going to study, this topic limit, for the very first time in your class 11th only. So yes, this is from class 11. Oh, not chapter 11. It's my bad, sorry. It's class 11. Okay, so yes, I have to be specific here, and this is from class 11. All right. So yes, now I can move ahead. So we have to evaluate this limit. Okay. Now let me make you understand first that what is the meaning of limit here. We have to basically put these values of x here. Okay. And we have to bring one answer. I know I'm not going to make you understand here the meaning of limit, because for that, I'll make another video where I'll talk on the concept of limit. Okay. So in this video, I'm just going to solve some questions. That's it. So here, how we can solve this question, we have to directly put the value of limit. But as you can see in this question, if you put the value of x, which is 0, so this will become basically root 2 plus x is 0 minus root 2 and then upon x is 0. Now, can you notice we are getting root 2 plus 0 is root 2 and root 2 minus root 2 is 0. We are getting 0 upon 0 form. Do you know that this is basically indeterminate form? Okay, this is called indeterminate. Okay, indeterminate form. And whenever we get indeterminate form by putting the value of limit, we cannot directly put the value of limit. We have to do something. That means we have to simplify this. So what we are going to do, we are going to simplify this first. The best simplification here I can see is doing the rationalization. So what I'm going to do, I'm going to rationalize this. So limit x tends to 0. Now, of course, I'm going to rationalize the numerator here. Okay, so root 2 plus x minus root 2 upon x. And then what is the meaning of rationalization? We have to just multiply and divide by the same thing by just reversing the sign. So here we have minus, so this will become plus. And of course, in the denominator, the same thing we have to do. So root 2 plus x plus root 2. Now, next step, of course, limit x tends to 0. I hope, because I'm assuming that you are in class 11th now, and you know that in the numerator, we are having the form a minus b into a plus b, and a minus b into a plus b formula is a square minus b square. So this is going to be root 2 plus x, that means a square, minus b square, that is root 2 squared, upon the denominator part, which is x into root 2 plus x plus root 2. All right, so now the next is limit x tends to 0. Of course, you know that the square and square root will get cancelled. So this will become 2 plus x. Minus here also square root and square will get cancelled. So only 2. And then upon the same thing, x root 2 plus x plus root 2. And now this 2 and minus 2 will get cancelled. So what we are getting? We are getting limit x tends to 0, x upon x root 2 plus x plus root 2. Now here you can notice that this x and this x will get, of course, cancelled. So now what we are left with? We are left with limit x tends to 0, 1 upon root 2 plus x plus root 2. Now you can notice here, we can now put the value of limit, which is x is equal to 0. Because now we are not going to get any indeterminate form. So yes, we can directly put the value of limit here, and that will become 1 upon root 2 plus x is 0. So 0 plus root 2, which is going to be 1 upon root 2 plus 0 is root 2 only. So root 2 plus root 2 is 2 root 2. Now, like in general, we do not keep irrational number in the denominator. So if you want, you can also rationalize the denominator here by multiplying with the irrational number in the numerator and the denominator. We have to multiply and divide. So this will become root 2 upon, this is 2, root 2 into root 2 is 2. So the answer is root 2 upon 4. I hope I got the correct answer. And yes, the answer is root 2 upon 4. If you want, you can also, of course, leave the answer at 1 upon 2 root 2. But if you want, you can also rationalize your answer and you can give this as the final answer. All right, we are done with our first question. Let's move on to the next question. That is the second question. And the second question says, evaluate limit. In every question, I'm just trying to cover as many formulas, as many concepts as possible, okay? So limit x tends to 2x raised to 5 minus 32 upon x cube minus 8. Now, let us understand one formula first, and then we will start solving this particular question. So there is a formula that if we have limit x tends to a, x raised to n minus a raised to n upon x minus a. That means whatever we have in the denominator at the base, and if we are having the same thing in the denominator, then the formula is n into a raised to n minus 1. Yes, this is the formula. Okay. So basically here in this question, we are going to use this particular formula only. Okay. So as you know, I always write down or keep my formula in the cloud, because I love clouds. So yes. So yes, this is the formula which we are going to use for this particular question. Now we can start solving this. So I'm writing the solution here. So you can write down this as limit x tends to 2. Here a is 2, right? Because of course you can see here is a, and here at the place of a we have 2. That means the value of a is 2. Now you can see that because here is a, here also we want a, right? But here we have 2, but here we have 32. So we can do something here. What we can do, we can write down this as x raised to 5 minus 32 we can write down as 2 raised to 5. And you can see that we got a also, correct? Upon x cube as it is. I can write down 8 as 2 cube. You can notice here that still we are not having this formula, x raised to n minus a raised to n. Of course, we are having x raised to n minus a raised to n. But we are not having that x minus a, right? We're not having that x minus 2, anywhere. So what we can do? We can do a very simple step here. We just have to write down x raised to 5 minus 2 raised to 5 as it is. I am going to divide here the denominator by x minus 2. And if I'm dividing the denominator by x minus 2, just to convert it into a formula, I'm going to do the same thing in the denominator. So x cube minus 2 cube upon x minus 2. So now this is balancing it out as well, right? Now you can see that in the numerator, x raised to 5 minus 2 raised to 5 upon x minus 2 is in the formula of x raised to n minus a raised to n upon x minus a. And same thing in the denominator also. X raised to n minus a raised to n upon x minus a. Now there is one property of limit that we can distribute limit, okay? So you can see that we have limit one time, but we can write down this as, by distributing the limit in the numerator as well as denominator, this will become limit x tends to 2, x raised to 5 minus 2 raised to 5 upon x minus 2. And then this everything upon, again, limit x tends to 2, x raised to 3 minus 2 raised to 3 upon x minus 2. And now we can see that we are having the same form in the like the formula which we have used just now in the numerator as well as denominator. So because this is in the form of limit x tends to a, x raised to n minus a raised to n upon x minus a, we can use the formula n into a raised to n minus 1. So here n is 5, a is 2, n minus 1, that means 5 minus 1 upon, using the same formula, n is 3, a is 2, n minus 1 is 3 minus 1. And this will become 5 into 2 raised to 5 minus 1 is 4 upon 3 into 2 raised to 3 minus 1 is 2. Of course, this will become 5 into 2 raised to 4. Like if you want, you can use the property of exponent here, which will be 2 raised to 2 and then upon 3. How I did this? I used the property of exponent. If we have a raised to m upon a raised to n, that is same as a raised to m minus n, right? So using this formula, 2 raised to 4 minus 2, right? Because we are having the base 2. And this will become 5 into 2 square is 4 upon 3. So the answer is 20 upon 3. Yes, I hope the answer is 20 upon 3 here also. Yes, this is the correct answer, 20 upon 3. Now we are done with this question also. Now let's do another question, which is almost similar like this, but here you will see something different as well. Okay, so for that, let me write down the question. Limit x tends to 0, root over 1 plus x minus 1 upon x. Now, first of all, of course, you can directly put the value of limit and you can see that this is going to be in indeterminate form. Okay, so x is 0, so that means root 1, which is 1. 1 minus 1, 0 upon 0. So this is 0 upon 0, which is an indeterminate form. That means we cannot do this, right? So what we can do here, we can also do some substitution here, okay? So what I'm going to do, I am going to put here 1 plus x equals t. Okay, now when I'm substituting 1 plus x equals t, I have to also change the value of limit, okay? So when x tends to 0, okay, this was when x tends to 0. Now because we have put 1 plus x equals t and x was tending to 0, so this will become 1 plus x is 0 and t, so what is the value of t? T is 1. So now t is tending towards 1, okay? So this will basically become limit t tends to 1, okay, root over 1 plus x we have taken as t, so t minus 1 upon x, right? So from this, what is the value of x? X will become, from this x will become t minus 1. So we can write down this as t minus 1. Now this we can write down as limit t tends to 1, root over t is same as t raised to half. And can you notice that 1 we can also write down as 1 raised to half. correct? Because 1 raised to half is same as 1 only. So even if you write down anything on the power of 2, it is going to be 1 only. Okay, upon t minus 1. Now, can you notice that this is again into the formula of limit x tends to a, x raised to n minus a raised to n upon x minus a. Okay, instead of x, we have t here, and at the place of a, we have 1 here, right? So we can use the formula. By using formula, it is n into a raised to n minus 1. What is n here? N is half. So half into a is 1 raised to n minus 1, which is half minus 1. No need to solve that part also. Why? Because you know that 1 raised to anything is going to be 1 only. So the answer is half into 1. So this is the final answer. Half is our answer. I hope you understood all the 3 questions which I have done till now. I have taken some more questions, and the questions are okay. For example, a very basic question. A very, very basic question. Okay, this is our 4th question, and the question is evaluate limit x tends to 2. Sometimes we do, simple questions also, because, like normally in exams, we just do some mistakes in the simplest question. So that should not happen, right? So yes, how to solve this? It is very much obvious, very straightforward. You just have to put the value of limit directly. Okay, here you don't need to simplify this. You don't need to do anything else. You can directly simplify this by putting the value of limit, because you are not getting any indeterminate form. Okay, so directly the answer is 2 raised to 4, 3, and then into 2 raised to 2 plus 2. Like, it's a one line answer. This question is basically for 1 mark. So 2 raised to 4, 16 plus 3 into 2 raised to square 4, which is 12 plus 2. So the answer is 16 plus 12 plus 2. This is going to be 30. And this is our answer. Okay, so we have completed this question also. Let's do one last question. So basically in this video, I wanted to cover 5 basics and like basic questions of limits and important also. So I have covered 4. Let me just do one more question with you. And which is this question, where we are going to do some factorization as well. So limit x tends to root 3. And I have x squared minus 3 upon, very simple question. It's just you should know how to factorize it. 3 root 3x minus 12. I have practiced so many questions of like these topics, that I know once I look at these questions, I'm like, I know what to do. Like when I look at this question, I know that I have to factorize the denominator here. Okay, so that will of course come if you will start practicing properly. So like this is what you can do from your side. Practice, practice, and practice, because practice is the key here in mathematics. If you are practicing, you are doing enough. Okay, because practice will make you perfect. All right, yes, we can now move ahead. X squared minus 3 upon. As I said, when I look at the question, I know that I have to factorize here. So what I'm going to do, I'm factorize the denominator. I will factorize the denominator, so x squared plus. I can write down 3 root 3x as 4 root 3x. And because I want here 3 root 3x, I'm going to subtract this with root 3x minus 12. Now you can also notice, because in factorization, we have to just cross check also whether we are getting minus 12 or not. Yes, I am getting minus 12 if I'm multiplying this. 4 root 3 into root 3, 3, 4 into 3, 12, and plus minus is minus. So I'm getting minus 12. Am I getting 3 root 3x when I'm subtracting 4 root 3 and root 3? Yes, I am getting 3 root 3x. So we are good to go. So now next is limit x tends to root 3. And x square as it is, we can write down 3 as root 3 square. All right. Upon. Of course, I can take here x common. So this will become x plus 4 root 3. All right. And here I can take root 3 common. So I'll be getting x. Of course, I've taken minus sign common. So it will become plus sign here. And I want 12 here. So root 3 into 4 root 3 only will give me 12. So if I write down 4 root 3 inside the bracket. Now we can write down our final steps. So limit x tends to root 3. Of course, in the numerator, it's very much obvious we are going to use the formula of a square minus b square, which is a minus b into a plus b, which is x minus root 3, x plus root 3. And in the denominator, of course, when you will take x plus 4 root 3 common, we are getting x minus root 3, correct? See, x plus 4 root 3, x plus 4 root 3 is present. So we have taken that common and then we are left with x minus root 3. Now, of course, x minus root 3, x minus root 3 will get cancelled. I love to cancel things when I get something like this, where we can cancel things, it's like the most satisfying thing. Okay, so yes, now we can write down the next step. Of course, let's not waste our time and directly put the value of limit, because we can now put the value of limit. Now, in this question also, if you notice that when you directly put the value of limit, which is root 3, you will be getting something like indeterminate form. Okay, we cannot do that. When we cannot do that, we have an option to simplify the question and then put the value of limit. That's it. So here, if I put the value of limit, this will become root 3 plus root 3. And here at the place of x, again, root 3 plus 4 root 3. What is root 3 plus root 3? Answer is 2 root 3 upon. What is root 3 plus 4 root 3? Of course, you have to add the this part, because here, if it is nothing, that means 1. 1 plus 4 is 5. So answer is 5 root 3. Root 3 will get cancelled, and our final answer is 2 upon 5. And there also I'm ending my video. So yes, I hope you have understood all these 5 questions which I have basically explained in this video. And thank you so much for watching my video, for watching the video till here. If you have watched it till here, thank you so much, everyone. And as I said, that I'll be now active because I was busy in some work, and now yes, I will be active and I will be uploading basically videos every single day. Thank you so much. See you soon in the next video. Goodbye, everyone.